Hi, my name is Krista Oswald, and I will be discussing how increasing temperatures are driving population declines in a South African biodiversity hotspot indicator species, the Cape Rockjumper. Reporting rates for the rockjumper have shown populations are in decline in areas of their habitat with the greatest warming. Like most of the birds discussed here, the Cape Rockjumper is range restricted to the mountains, which means they will be unable to relocate to more suitable habitat either further upslope or further towards the poles, should theirs become substandard. Not only are they restricted to the mountain peaks, but they are further restricted to specific vegetation within those peaks, low scrubby mountain fynbos. The fynbos ecoregion is by far the world's smallest floristic kingdom and is predicted to shrink with climate change. As rock jumpers are inextricably linked to their habitat, changes in demographics of one may indicate risks to health in the other. Rock jumpers became the focus of intense research from 2015 to 2018 to try and identify why their populations were decreasing in apparent correlation with increasing temperature. This led to a few possibilities, including physiological sensitivity, behavioral changes, and decreasing reproductive success, all of which may lead to decreasing overall population size. Most likely, the decrease in rockjumper occurrence comes from temperature effects on their reproduction. Rockjumpers have increased predation and lower nestling quality at increasing temperatures. 2 years of video data showed that nestling mass gain was lower on days above 22.4 degrees Celsius. Over the same 2 years, we also found nests were more likely to fail on days with temperatures above 25 degrees. Now, what do these temperature thresholds mean for rockjumper populations? Given how rockjumpers will be unable to shift their habitat, we wanted to predict the increase in days rockjumper nests would be vulnerable under future climate change scenarios. We created risk assessment maps using temperature data from within the breeding season. Here, we can see that the consecutive days where nestlings gain less mass will increase by about 25 days by the year 2080, while days with increased probability of nest predation will increase by about 20 days. However, when we combine the number of consecutive days over 22.4 degrees and total days over 25 degrees, the days nests are vulnerable increased by about 50 days by the year 2080. Not only is rockjumper reproductive success predicted to feel the negative impacts of climate change within their existing habitat, but the habitat itself is predicted to decrease dramatically in the coming decades. Again, if we look at the current distribution of the fynbos ecoregion, at present it covers about 90,000 hectares of the southwest corner of South Africa. Mountain fynbos makes up about 1/3 of the fynbos itself, with only some of that 30,000 hectares inhabited by rockjumpers, and many of these peaks are separated by hot, dry lowlands, ostensibly making them sky islands. The fynbos is projected to decrease by the year 2050 due to climate change as well as the encroaching invasive plant species, the spread of which is itself exacerbated by climate change. In summary, climate change is likely to negatively affect the rockjumper through two main areas: the more direct negative effects of decreasing parental care and increasing predation risk at higher temperature, and the decrease in suitable mountain fynbos habitat. As such, it is important to continue placing emphasis on protecting current areas of rockjumper habitat and perhaps instigating a program of invasive plant species control throughout the fynbos. Thank you for listening. I'd like to thank the organizations that provided additional funding, my co-author Shannon, supervisors, colleagues, and assistants who helped with the work. And I'd be happy to take any questions.